Hello everyone, welcome to Studitable. My name is Swati, and in today's video we'll be talking about SSH, what SSH is, how does it work, the introduction, and then we look into how to generate SSH keys and use them to log into GitHub. Okay, so if you are someone who has very limited knowledge on Git, or if you are someone who wishes to know more about Git, then there is a video on Git from the channel Studitable. Link will be there in the description below. Go check that out. Okay. So without much further ado, let's start the video. So the introduction of SSH, that what is SSH? So SSH, also called as a secure shell, is a protocol that is used to connect one computer to another computer. So no matter where your PC is, if you are residing in one city and you wish to connect to a PC in another city, then through SSH the connection is possible securely. Earlier too there were methods used, but SSH is a secure way to connect one PC to another PC, and it allows us to connect securely from one computer over an unsecured network, which means that if you send data from one computer to another computer, that there is a possibility for the data to be breached, or there can be a cyber attack, and someone can spoof the data. There can be a man in the middle attack, or the data can be compromised. So the connection to be secure, and the data whatever is being sent is securely sent. SSH is employed in between so that the connection is secure and the data is not lost in between. And SSH was developed in 1995. That is, before that, Telnet was a popular tool to make connection between two computers. But since Telnet did not employ or deploy encryption, so the data that was being sent, or the connection that is being made between two computers, whatever data was being sent, that was sent in the plain text format. That is, there was no encryption in between. So there were cyber attacks happening over there. There were a problem of spoofing. There was a problem of eavesdropping or other kind of vulnerability. So telnet was not secure. So SSH was developed in 1995, and since then SSH is a very dominant way to make connection between two computers. That is, we can also call them as the client or the server, or the host to the remote server. Okay, so the connection is secure here, and since then SSH is being used as the main method to connect two computers in a remote location and to send data securely. Since it was designed to replace older methods like telnet, which transmitted data in plain text, so SSH became a very popular and a very prevalent method after its advent in 1995. And in 2000, over 2 million people were using SSH, and now there are a billion people who employ SSH to their files and to send their important data from one place to another place securely over the internet. And SSH uses the TCP protocol 22 to use to make the connection, and after that, once the connection is made, then the files are transferred. So there's a common question that comes into the mind of the receiver and the sender, that how does SSH work? That if you're working with SSH for the first time, then you may think that, okay, how does this work? What are the steps in between? What is the first step that happens? How does SSH verify the client? And after that, what is the next step? How does the server verifies the client? How does the connection happens? And what are the steps in between? So how does SSH work? Well, SSH protocol uses symmetric encryption, asymmetric encryption, and hashing to secure transmission of information. Okay, so there are three stages, but before that, let's understand what is symmetric, asymmetric, and hashing. Symmetric encryption is that key this single key is being used both for encryption and for decryption. So this is a shared key that is being generated on both the server and the client, and both of them generate the same key, and the same key is used for encryption and decryption, and it's a very secret key that is generated at session time. And this is the symmetric encryption, that only one key is being used. Asymmetric encryption, there are two keys used, that is, one is the public key and one is the private key. Public key for encryption and private key for decryption, and both of public key can be transferred, and private key needs to be kept secure. And the third is hashing, that is for hashing. any kind of text or any kind of file, important file if being sent out, then a hash algorithm is applied onto it so that the message or the information appears very gibberish to anyone who sees it in between, so he doesn't understand what's being said. So that's a hash algorithm being applied to it to make the message legible. Okay, so the steps in between are: first, the client is verified by the server. How that happens? If the client is making the connection for the first time, then he needs to manually verify the server. When the client connects to the server for the first time, then the server sends a public key to the client. Okay, manually verify the server by checking the public key into the SSH known host file. We'll see where you can find the SSH known host file, and then you will verify the server by checking that file, checking that key in that file. Okay, once the server is verified, then the second step is to generate a session key to encrypt all the communication. So how does the session key is generated? The session key is generated using a version of the Hellman's algorithm, and both of the parties use the same algorithm, and the session key is generated, that is, it is a shared key, that is also known as the secret key, and both the parties generate the same key with the same algorithm, and the key is never transferred in the process. That is, client doesn't send the key to the server doesn't never send the key to the client. Both the ends generate their own session key using the same algorithm, and both the keys are same, so that session key is used to encrypt all the information. So any kind of information that being sent from the server to the client, or from the client to the server, the session key is employed in between to encrypt the entire session with that key. So anything in between cannot be decrypted, because the session key is only with the two parties that are in contact with each other, that is the client and the server, or the host, or the remote machine. Okay, so the session key is generated, and the third is the authentication of the client. So the authentication of the client happens in a few steps. Number one, the client starts by generating a key pair using the SSH keygen command. It can also include with the type of the key he wishes to generate, and after the key is generated, he the client or the host computer copies the public key and sends it to the server. The server, once it receives the public key, it checks the authorized keys file onto his system to verify if the key are there or not. If the server generates a random number and with the public key, encrypts the message and sends the encrypted message back to the client or to the host. If the host has the correct private key, then he will encrypt the message and um, obtain the random number that was sent by the server. So once the random number is obtained by the client, he combines it with the session key that was generated in the second step. That is the common key that is there with both the client and the server, and it uses the session key. This key is used to encrypt the whole conversation, the whole session. So along with the session key, the random number is combined and the MD5 hash calculated. That is the MD5 hash of the value, that is the session key and the random number combined. The MD5 hash is calculated. MD5 is sent back from the client to the server. Why is it being sent? Because the client sends the MD5 hash back to the server to verify him that he has decrypted the encrypted message that was sent out by the server using the public key, and the client has now decrypted it using his private key. So since the server has the same session key, so what he'll do, he will create his own MD5 hash using the session key and the original value the random number that he generated. He will generate his own MD5 hash. So if both the hashes match, then the server knows ki, okay, he is the correct client, and the client is then authenticated. So there are some features of SSH that we look into. The one is encryption, that is SSH provides us encryption, that is the whatever is being sent out from the client to the server. The exchange between the server is encrypted. So it allows confidentiality and prevents unauthorized attacks on the system, that no one can eavesdrop, no one can do a man in the middle attack, or there is no harm to the data being happening in between. Tunneling is that we can create secure tunnels, that is a secure channel in between for forwarding network connections over encrypted channels. That is, whatever files or whatever things that we need to send from one computer to another computer in a SSH session, then we can create a tunnel that is more like a alternative to VPN. That is, there is a secure channel established, and the data can be sent out in a very secure manner. And number third is authentication. Since SSH uses public and private key, which is the key pair for authenticating for the client, and the public key is there on the server and the private key is securely saved with the client. So the key pair provide more security than password, because passwords can be tracked or passwords can be compromised, but since these two key pairs are more secure as compared to passwords, so SSH uses key pairs to make the connection more secure. Okay, so here is an SSH client that initiates a connection by contacting the server. So server sends the public key that it has. This is the first time connection. Then when the server is authenticated, then the parameters are negotiated. That is, they negotiate the parameters and open a secure channel, that is a session key is generated in between using the Diffie-Hellman's algorithm, and that shared session key is generated on both ends using the same algorithm. So the session key is never transferred in the process, so it's completely secure, because if anyone is there in between eavesdropping, then he doesn't know which algorithm is being used, so he'll never have the session key. So there is no possibility of the data being breached. Once the parameters are negotiated and the secure channel is opened, then the can log into the host operating system once the client is authenticated. Okay, so this is the process of connection between the SSH client and the SSH server. It uses the asymmetric keys, symmetric keys, and the hashing. And there are various steps of how the connection happens. All right. So now in this, we'll see the commands in this video. That is, first we'll see the SSH folder. That is, if we have what is there in the SSH folder, we are known host folder, and also we create whatever keys we create that are stored in the .ssh folder into our system. Okay, so we'll first move to that folder, and then we'll create a key. Okay, we'll find out about SSH agent. What is an SSH agent? SSH agent is a kind of a daemon program that runs in the background and keeps the SSH keys in memory, so that whenever we need, we can refer to the SSH key, because the SSH agent keeps running in the background and the SSH key is there in its memory, so it's never lost or it's never removed, until unless we remove it manually. Then we'll copy the key generated to the GitHub uh, SSH key section, and then we'll verify if the keys have worked or not. Okay, so now let's see and run these commands. Okay, now so we will be running those steps, but before doing those steps, we need to verify if SSH is there onto our system or not. So in Linux, a Linux based system, and also in Mac, SSH is pre-installed. So for that, we can pass the command to check if SSH is there onto our system by passing the command ssh/v. V is for version, and here we will find the SSH version onto our system. And once we have verified that SSH is there onto our system, then this is a Linux based system. So for Windows also, if we can check for SSH version, but it's not there. If it's not there, then for alternative for SSH is PuTTY. We can use PuTTY as an alternative to SSH, or for Windows, we can go to settings, to system, optional features, and if OpenSSH is not installed, we select add a feature, search for OpenSSH client, and we can select install. Okay, and for Ubuntu also, we can upgrade our Ubuntu packages, install and configure the SSH server according to the steps. All right, so once we have verified the version, now we will go to the specific folder. So SSH resides in the folder tilde /dot ssh, and this is the folder of SSH where all the SSH keys are stored. So to see the contents, then these are the contents. Okay, this is one key generated into my system. In known host file, you will find all the verified hosts that are stored once the SSH makes a connection to some other server or some other computer. So once the verification is done and once the client is authenticated or the server is authenticated, then the information goes into the known host. So in if you reconnect to the same server or to the same host, then the ID or any key that you need, then it will be referred to in the known host first, and if it's found, then the reconnection or the re-verification doesn't happen. But if it's a new connection, then everything happens from scratch. All right, now we will be creating, okay, I'll get out here, and now we will be creating a key pair here. So for that we'll be using SSH slash key generator, and slash tt is for type. The type of key that I wish to generate is ed25519. So this is the latest or the most used key version that is used in SSH, and this is a newer version. In if you have a legacy system, if you have an older system, then instead of ed25519, RSA can also be used. But since this is more secure, so this is more preferred to be used. Okay, and then type in a username. After this, we'll type username or email. So here I'll type username, and this is the username of my GitHub account. Since I am generating a key for my GitHub account, since this is a Git specific SSH keygen, so you will be writing, or we will be writing the username or email of the GitHub account that we have. So this is the username, and now the key pair is generated. So if you have multiple keys with the same name and you do not wish to keep this name because ambiguity, that you can get confused ki, okay, what is the name matlab, for what the key pair is, then you can change the name here. So we enter the file to which we save the key. So we will be copying the same path, but instead of ed25519, we will be using our specific name that we wish to use. So here type the same, or you can also copy, and here I wish to name it as git gen. Okay, and once I enter, so we can enter passphrase. I do not need any passphrase, so I'll not be entering any passphrase here. And now the key is generated here. Okay, so the next step to do is, once the key is generated, is that now we will look at the SSH agent. So we'll pass the command eval slash dollar SSH agent, and this is the agent. Now this is the agent that is saving the SSH keys that are generated, and it's saving them in its memory. So I will be deleting this SSH key once the session is completed, and this is the agent for the, what is the agent here? Agent will save the SSH keys into memory. So whenever we need the SSH key at any point of time, then the agent will fetch it for us, because it will keep it in memory and it keep running in the background. Okay, once we are done, now what we will do is we will copy the SSH key. The command to copy is in Mac is pb copy, and the location of the SSH file dot ssh, and the name of the file that we created is git gen. Okay, dot pub. We have to write pub. Why? Because we need to copy the public key. Private key is to be kept secure. So the public key needs to be saved onto the GitHub, so that whenever we make a connection, then the public key is used to verify, and the public key, along with the public key, the GitHub will contact the client, that is you, and with the private key you will verify, right? So we'll copy this. Once it's done, we'll go to GitHub and paste this key onto my GitHub account. For that, we'll go to settings. Okay, and here in the SSH and GPG key sections, we'll we'll enter a new SSH key. Okay, the title can be anything, you can name anything you want. So I'll use personal laptop, and then authentication type is authentication key because I'll be authenticating it, and copy the key. So once it's copied, we'll add the SSH key here. So it will ask you to verify. So let's verify with the password key. Okay, it's you. Once it's done, the key is now added. Okay, I'll delete this key after this session. Once we are done, we'll come back to terminal, and now we'll do, we will verify the key here, the SSH, and what we'll pass here, slash, if the GitHub has been, the key has been accepted, and now we can connect to GitHub. Key is successful. Once we do this, we'll see what message we'll get. The permission is denied here. Why? Because the public key is not accepted right now. So what we'll do here, open the config file here. Open, the location is /.ssh folder, and then in there there was a config file. So we'll open the config file here. So once we open it, we'll see the host is GitHub, add key to agent, yes. The identity is git, the key is wrong, so we'll use the key that we generated, git gen, that we just created, and ignore unknown. If we are creating a passcode, then we need to remove ignore unknown and use keychain, yes. Yani you will be using use keychain, yes, if you are using a passphrase. But if you're not using a passphrase, then ignore unknown, use keychain. This will be done. Once it's done, close, and now we'll again check. Now I'm successfully authenticated. The message is, hi Swati, my username, you are successfully authenticated, but GitHub does not provide shell access. So if you get this message, now GitHub is now successfully authenticated, and now you can transfer your files from your system to GitHub through SSH. Okay, or through, if your Git is on a remote server, then the connection can happen, or you can connect to your server through SSH. So if you are getting this message, so this means now the key has been successfully verified and you are now logged in through SSH. So if you found this video useful, please give it a thumbs up. Do not forget to share it with your friends. Okay, and please subscribe to the channel. If you keep learning, keep growing. Thank you very much.